Gonna start streaming. See my cart? No, I just have a bunch of random shit in there. Okay, so what happened yesterday? Basically, we have this that I printed, and I could open up Infusion, but anyways, the mechanism of this was designed to, first off, there's a little chimney, and if we do this right, you have two balls stuck in the chamber. Now, the first problem is they just roll out. So I didn't make the dimensions correct. But the other problem, and this one's way worse because I don't really know how to resolve this, is first off, okay, so the it doesn't push it, but the fact that it's too high is not really an issue. But if I lift this up and raise it to simulate what it would be like, and then I turn it, you can see that. What's up? Okay, so basically, um, you can see here that this thing gets uberly stuck. Like, there's just no way it's gonna push it through. So that's a huge problem. So my solution is I'm going to get I bought one of these solenoids, and I, instead of using two parts like this, the idea is I'm just going to use one part. I'm going to make this much shorter. I'm just going to push it into the flywheel. But the thing is, this comes tomorrow, so right now I just want to do something kind of fun and finally look into getting Blink working on my Pico. Specifically my Pico W. And the thing that we're going to try to do is we're going to try to do use this time of flight sensor with my Pico W. So I don't think it's supposed to be that hard, right? I wonder if I can just run this. Requires rust nightly? What the hell, bro? So can I just run this? But it needs its own installer? You can't just do cargo install? I don't want to do a Wi-Fi scan. Okay, well, first things first. Um... Okay, let me do this. No, that's not gonna work. Okay. No, it actually might be. Hold on, I gotta go get a micro USB cable. Okay, so something that I think would be fun to do. Yeah, it is rust time, baby. It's definitely rust time. I have been itching to do just a programming thing for a while, especially a programming thing with in a language that actually is nice to use. I don't know. I think this is probably going to be pretty painful, to be quite honest, but we will see. We will see. Okay. Oh wait, do I have to hold boot? No, I don't think I do. Okay. So the main thing that I want to do is I want to get this. Yeah. I'll probably want to maybe hop on Discord or something like that. Honestly, I can stay in the voice chat if you just want to provide commentary, but I understand if you don't want to do that. But basically, we have this thing called the time of flight sensor, and what that does is it shoots a little infrared flash out, and um, and it based on the time that it takes to come back, it determines the distance. And so what we're going to use this for is determining whether or not we're sort of out of bullets or something has gone wrong. So we have, and I don't think you were here maybe when I explained what went wrong with yesterday's design, but there are a ton of bugs, and this thing just basically does not work. The most serious problem, which I don't really know how to resolve besides using a different part, is so the first bug is this was not supposed to just freely roll out. This thing here was supposed to be low enough that these couldn't roll out. But that's not really that big of a deal. The bigger issue is if I'm going to raise this up to simulate what it's like, and then I move the servo, here's what happens. This thing just gets totally jammed in here. It's actually not. It's only 22 millimeters. So it's actually not that big. But the biggest problem is that it just gets totally jammed in there. So That's no good. So the solution is to use a solenoid. A push-pull solenoid. And this basically, it has a coil of wire which becomes an electromagnet. Oh no, dude. Yeah, okay, so actually that's a good point because I was sort of thinking about BBs and using like compressed air with BBs, but the problem is if I'm going to cover my canvas, I would need like 375,000 BBs, so it's just not going to work. Um but yeah, so what a solenoid is it's basically just a coil of wire, and inside there's some magnetic thing. And when you give it current, the coil of wire turns into electromagnet and it propels the thing forward. And then when you disconnect power, the spring pulls it back. So this is a much simpler design on how we're gonna do this thing. They'd splash probably for it. Well, so we don't. So I'm not using paintballs, right? I'm using Nerf balls that are going to be covered in paint. And obviously, I mean, not obviously, but it's likely that I'll have to pivot this and not, you know, as I'm going along with this, we'll see the failure points. But the reason for this is because I don't want the splash. I want to sort of minimize unintended. I want to deliberately put a dot of paint in this place, and with the splash, you get all sorts of weird dynamics and shit. But let's see. This thing seems like such a big thing. Is there just a guide? Oh yeah, I don't know if I said. Yeah, I just ate one of the balls. Bro, that's so good. No, it's blackberries. That would be so fucking funny though if I just casually was snacking on these. Oh my god. It's so funny. Um Whoa. Tasks get transformed at compile time into state machines? That seems pretty sick. Um I have an ESP, so I could use ESP. But I love the Pico so much. But this, I don't think that this. Hmm. Okay, wait. Are there guides? Okay, here's the get started. So you want to try Embassy? Wait, can I change the freaking theme on this thing? Dude, what the fuck? Wait. Oh, so this is just the README? Oh, I don't know. Yeah, I just want to do the getting started. I can't. Oh, wait, I actually want to see this. Wait, is that Pico W? Yeah. Okay, so you want to try Embassy. To get started here, there are a few tools you need to install. First up, Rust up probe rs. All right, let me just run the probe rs command because I was looking at that. Wait, what the fuck? Why is that not a copy button? Wait, this isn't gonna work on Windows. What's IRM? I've never seen IRM. Oh wow, it's an alias for that's so fucking silly. All right, cool. Getting a board with examples. Embassy supports many microcontroller families, but the quickest way to get started is by using a board which Embassy has existing example code for. Oh, that's such an L, bro. I don't think because okay. Oh my god, look at this wiring, dude. That's pretty sweet though. I don't have just a normal Pico. What was that thing called? A CYW? Maybe it's an RP. Wait, I just want to take a real guess. This is a template for running an application in Rust on the Raspberry Pi Pico W. I feel like we should just try this. Okay, wait, but how do we... Is literally all that we have to do just cargo run? Or... Oh, here we go. How does the cargo run command know how to connect our board and program it? There's a... Okay. Oh, whoa, look at that debugging. That is actually sick. That's really cool. Dude, Rust is so sick. Wait, so when they... Where's that example in Embassy's... but it doesn't actually... But it probably depends on probe. I don't really understand how these all relate together. Maybe I should just try ESP. Ugh, but I hate dealing with these ESPs because they don't. Well, let's just try it. Is this not gonna work? Wait, I don't understand. What is this thing? Whoa, this is so sick. I'm pretty sure this is KiCad. No, I don't know if it's KiCad. Oh, that's so cool. They designed a They designed this board specifically to be for Rust devs. Oh, okay. The issue is I don't have. There's no example for specifically the Pico W. Maybe we'll just try this. We'll just try the Pico and see if it works. So it's probably going to be under RP. But wait, oh wait, we cloned this. Okay, so let's just try this. Let's just try it. What's the worst that could happen? This repo is a little bit old, but presumably it knows how to flash my Pico. That's what probe RS does. I'm gonna finally change this just so I don't know. What is it called? Docs stream info. Let's change it to Rust on okay, hopefully that changed it. Dude, I hate that sound. On my laptop, I've disabled that sound because this is the worst thing in the world. It makes me want to die. Like, who thought it was a good idea to just constantly spam classic Bill Gates nonsense? Okay, let's see what code this actually run. Oh, great. Okay, so wait. A dead man. Okay, I saw this, but look at how much. Oh, wait, this is actually fine. I thought that this was a lot more. Oh, wait. Oh, wait, hold on. Maybe I was just being a little silly. So if we go into this, no. Okay, I don't know what he's talking about. There was a Pico W example. Presumably this does not. Oh, I just saw this guy's YouTube video. Okay. When was this written? That's also a good question. 2024. No, I don't think that's the release date. Let's see. There's no dates on these things. Okay, whatever. Blinking the onboard LED is a pretty common first project within a new chip. It's also a useful indicator and debugging tool as you build out your project. Yeah, so true. With the RP2040 Pico Ws, this gets a bit trickier than with the regular 2040 Namely, in order to account for the GPIO pins needed to drive the Wi-Fi chip, the onboard LED was moved from one of the pins controlled directly by the RP2040 to one of the pins controlled by the Wi-Fi chip. This makes blinking the LED a bit harder since you need to set up the Wi-Fi coprocessor in order to set the LED high or low. Yeah, this shit is totally stalled. I don't really get it, but whatever. Where the hell is my fucking... Okay. Wait, why don't we just clone Embassy and just see what's up? I'm just going to try to run this. Wait, but are these examples? I don't think these are examples. This is just a library. Is there no... Okay, wait, let's just clone it, and I'm going to search in the examples folder for this chip, this Wi-Fi chip name. Ugh. What? What the fuck are you talking about? Oh. Okay. Yeah. Okay. So, we're going to search, find in folder, and we're going to look for this CW. Is that what it's called? No, Oh, examples RP. Wait, can we just look in there? Wait, are these all examples? Oh. Wait, can we just search in here for pico W? Oh, nice. Does not work with a pico W. See Wi-Fi blinky. Oh, hell yeah. Okay, sweet. Oops. How do I run one of the examples? All right. Okay, I'm back. So,
Not gonna freak if you leave it open when you leave. If you go to the bathroom.
if I go to the web. Okay. So, Wi-Fi blinky. So how do we run this? CR dash dash bin Wi-Fi blinky. It's crazy. All right, let's just read through this code while it's waiting. Is the Pico W schematic fully open source? Does a datasheet actually give you the full... Whatever. It's not like I care. I don't know what any of this stuff does. Deformat. Bind interrupts. Alright, I need doc strings. I need the docs, man. This is wild, though. There's just a binary that you include. Okay. I mean, this will be freaking rad if it works. This would be so sick. Wait, can't I do this? Okay. What's Rust Rover? Oh, cool. Should I try this out? Wow, that actually does look kind of sick. I'll have to try it out. Wait. Can you hear me? It's because I'm compiling freaking 300 packages, bro. I know, I can see. Okay, so I'm using like a. Wait, can I listen to it? Okay, wait, hold on. How does it sound? Wait. Test, test, test. Oh wow, it's so laggy. Oh my god, it's actually crazy laggy. Wow, that actually does look kind of sick. My audio sounds fine though, right? Wait. Can you hear me? It's because I'm compiling freaking 300 packages, bro. Wow, why is it still delayed though? I know, I can see. Okay, so I'm using like a. Okay, wait. It seems like it just got unstuck. Oh no, but it's like literally getting like like I'm at like, yeah, it's like 2 frames a minute exactly. That's crazy. All right, but we're almost done compiling, so I feel like it should be fine. I mean, once it's compiled, it's just because Rust spun up like 4 threads and is compiling all this shit. But like once OBS gets its dedicated thread back or whatever, it'll be fine. But no, I have been thinking about. The thing is, I'm usually on my laptop, and I don't like. I usually like to be outside, but it's gonna rain today, so I didn't want to be outside working on hardware. But all right, wait, let me. But what was I saying? Is basically. Oh Jesus! No connected probes were found. Do I have to hold down boot cell? Wait, let me just try it again. I don't know. This is just a shot in the dark. Okay, my stream should be better now, right? Wait, hold on. I'll go to Discord. It lets me plug my Discord. Wait, hold on. Oh, close call. Yeah, it should be fine now that I'm done. Dude, we gotta make that an emoji. We gotta make that an emoji, bro. That's so funny. That's awesome, man. That's awesome. Okay, hold on. So, what failed? No, okay, so I saw this on, where was it? I think it was on this page. Okay, yeah, so this sounds like my issue. I just started out with embedded Rust. I was previously using RP-HAL, but lack of Wi-Fi means I'm giving Embassy a go. Immediately, while trying to flash to my pico, I was getting an error. Command I ran was run Blinky. No connected probes were found. The solution is hidden in the FAQ. How to deploy to RP20 without a debugging probe. I don't even know what that is. What is a probe? You need to update the examples rp.cargo.toml file. And you add this. Oh, interesting. Wait, but I thought I am using probe. If I look up probe rs. Okay, see, I have probe. So get all. Okay, let's just do probe rs list. So that sort of checks out. All right, wait, why don't we just try this solution? So in the cargo.toml, we're looking for the runner probe. Wait, maybe it's. Oh, maybe it's in this. Yeah, it's not the cargo.toml, it's the config.toml. Wait, what's up with this weird ass? Okay. Oh wait, is that just because this random ass escaping thing that he has here? Program not found. Oh, well that's even worse. Have you had that issue? I melted the button. What? That's so random. Oh, is that what he said? No, yeah, he said .cargo cargo.toml, but it's actually called config.toml. It's pedantic, no, but I don't understand. I don't have any context for this. Wait, I'm just gonna do this. Give me context for this discussion. What is a probe? I also have a Pico W, and I'm trying to run Rust Blink on it, but I'm getting no probe found. Oh, dude, this thing is so annoying. Oh, wait, no. Come on. A probe refers to a hardware debugger that interfaces with your development board. Wait, I have to keep all the escapes? Definitely not these. Definitely not those. But this one, yeah. But this looks like a real issue because %1 is not a valid Win32 application. Okay. Well, wait, hold on. This will allow you to flash the Pico without needing an external debugging probe. I don't understand. Okay, hold on. Wait, why doesn't the thing even say any of that? The embassy book should say, "Oh, you need this thing." I have another. I actually have another Pico. So let's just see, what is Pico probe? Yeah, I'm gonna go watch that video by that guy with the mask on. Um, I don't trust anyone with thumbnails like this. Why are you making thumbnails like this? Where's the other guy? Wait, why isn't it in my history? Oh, here it is.
And the Pico uses one called thumb for the ARM v6M architecture. To install the toolchain, we'll have to tell Rustad to the target. And we're going to directly run the thumb v6M none because it's not going to be running on any OS, and EABI, which stands for Extended Application Binary Interface, but you don't have to worry about that. Next, we're installing Fliplink with Cargo. You don't need to worry about what this does, but it's pretty interesting if you want to check it out.
Okay. Wait, who? This guy?
Now, from here we have three options.
Or are you talking about the other
Stick
guy?
to the one that matches your eyes.
You're probably talking about the other guy. Oh, okay. Oh, okay. Oh, interesting. Wait, do they sell that? Yeah, you're talking about this guy, right? Oh, wait. Uh. With the freaking hat, bro? Whatever. I don't want to roast him. He's probably a nice guy. Oh my god. Wait, can I just watch the video? I have one pico.
If you only have a single pico, you'll want to install ELF to UF2RS. Make sure to include the locked pack. This is it.
Okay. This guy sounds like he knows what he's talking about, man. Crab? Rust? Follow for more. Alright. Oh wait, maybe I just didn't have... Maybe I just didn't have this. That's why it failed. Because, presumably... Wait, what was the error that it actually gave? There was a no program found, but that I think is the wrong... I think that was the wrong thing, because I think that that was just an issue of the escaping. Yeah, no worries, bro. Peace. For sure, for sure. For sure.
If you're going to be attaching the pico as storage device to flash it. If you have more than one pico, you'll want to flash one with the Pico Pro firmware. I'll left a link with instructions on how to...
I want to figure out how to get rid of this freaking doubling of audio. It should do like a noise reduction where it checks desktop audio. Damn. Alright, whatever.
Do that on the article and on the description. Doing this, you'll turn one of your picos into a debug probe, which unlocks superpowers. You'll have to wire your picos like this. These two wires are optional, and if you add this one, you won't have to use two USBs.
The problem with this is I'm always going to forget this. Here we go. It's a disk drive. Okay.
Just this one.
Wait, hold on. What?
Which unlocks superpowers.
Wait, can I just try this again? Okay, I'm gonna remove the escaping and just see if that helps. Oh, yeah, you had to remove the escaping. Hell yeah! Brother! We have got Blinky running. That's so sick. Alright, so now we gotta edit the code. So now we want to make this the delay. Wait, why isn't Rust Analyzer giving me anything? Why did Rust Analyzer fail? Wait, what if I just open up only this folder? Hopefully Rust Analyzer will succeed. Okay, so soon we can get this thing wired up. And then later I'm going to do some CAD. I need to design this thing. Okay. Oh, they have a MIDI example? Dude, my bitrate is literally like 2000. It's just my shitty computer. Oh, it's so nice with the we need that backlight. Wait, no. Oh, there we go. All right. Cool. Okay, so now we want it to blink faster. And now we can just run. Okay. So it should blink twice as fast now. What? Oh, wait, do I have to, is this really how I have to cycle it? I have to do this, and then this, every time? Dude, that's brutal, because then you have to... Okay, but it is blinking faster now. So that's good. So now we want to, okay, now we want to wire this thing up. So now I got to show off a little bit. We're gonna test this out. This is gonna be a first. So, how do we want to do this? Bring this down. All we're doing is soldering some headers on. Oh, crap. Okay. Oh wait. Turn on our soldering iron. Get our solder. Put this trash away. Put this back. Dude, I knew spending some time to optimize the setup was like a good move. This is so good. Okay. Ay, ay, ay. Maybe I can just do it with one. It'll be good enough. Okay. Now we can just pull this down. Hold on. I need a I think it's probably made out of plastic, but whatever. Cool. That's it. That's all we had to do. Now just inspect. Whatever. It's fine. Now on the breadboard, so first off, we can take this back up here. Hey, that worked out pretty well. Okay, so let me look up how to let me look up how to do this. Uh, why is it called time of flight sensor? Oh, time of flight, bro. Am I stupid? Holy shit. The time of flight. Literally, that's what it is. Is it ST? Or is it Populo? Oh, no, it is. Okay. So this is the chip. Where's the data sheet? Oh, CAD? Wow. Okay, so for now we don't really need to show the wiring. I do want an overhead cam that I can switch to, like a nice high quality one. If any rich viewers want to fucking help me out with that, that'd be appreciated. Class 1 laser device. Single reflowable component. No additional optics. Single power supply. I2C interface. The vl53L0X is a time-of-flight laser ranging module housed in the smallest package on the market today. Okay. What's the difference between a time-of-flight and a LiDAR? What's the difference between a time-of-flight sensor and LiDAR? Oh, this just shoots out light. Can I want to, yeah, I want to read this because I want to see what the schematic is. The block diagram. No, I'm going to get some more coffee.
Are you going in, Park?
No.
Okay. Door open, no.
Okay. Single photon avalanche diode. What is I squared C? Can I just watch a video on I squared C? Wait, I actually like Great Scott so much. Great Scott is so good.
If you ever implemented a rather complex IC with many functions, like telling you the exact date and time, expanding your I/O outputs with 16 12-bit PWM pins, or receiving your favorite FM radio station in your project, then you might be familiar with I2C, also known as two-wire interface. It is a popular communication protocol that allows one or more master devices, in this case an Arduino Nano, to talk to up to 112 slave devices, to either tell them what to do or to receive data from them which they acquired. So in this video I will tell you the basics of the synchronous serial bus and present you a practical example with an Arduino and a TEA5767 FM radio IC. Let's get started. IC to the master device, I first had to create a small breakout board. For that, I simply scored and snapped a strip board, soldered 5-pin mail header onto its short sides, interrupted the copper traces in the middle, fixed the IC on the board with hot glue, and finally connected the mail header with the pins through silver copper wire. Then I connected ground, 5 volts, the antenna, and the audio output to my headphones according to my small schematic. The two I2C pins, SDA aka serial data, connects to pin A4 of the Arduino, and SCL aka serial clock connects to pin A5. The last remaining components are two 10 kilo ohm resistors, which act as a pull-up resistor for the two I2C lines. This is necessary because the devices have an open collector configuration, which means they can only connect the clock and signal line to ground. But since we need two stable voltage states to define the two binary states of a bits, the resistors pull the lines up to 5 volts. After powering up the circuits, it was obvious that the audio outputs would deliver nothing useful, because the correct code is still missing. The most important resource of information when it comes to I2C devices, or generally every IC, is the datasheet. There we can find what kind of bits or high-low states we have to send in order to tune in a certain frequency, mute the audio, or choose the correct region, so it's definitely a good idea to print out those pages. Firstly, we need to send a start condition, which means the serial data falls while the clock stays high, but don't worry, the wire library of the Arduino does this automatically when a transmission begins. Then we need to send the address, which is usually a fixed 7-bit value, which is always mentioned in the datasheet. Afterwards follows the RW bits, which is 0 if you want to write to the slave, or 1 if you want to read from the slave. Once again, the library handles this on its own, depending on whether you choose begin transmission or request from. An acknowledge bit is the next, which is sent out by the slave to let the master know that it is ready for the next byte, aka 8 bits of data. And here starts the fun part, since we need to send our 5 data bytes, which actually tell the slave what to do. It is pretty easy to choose most of the bits correctly by studying the datasheet, but the first and second bytes are a bit special. There we need to define the PLL value, which directly defines the frequency we want to tune in according to this given formula. As an example, I will use 95.6 MHz and get a decimal value of 11,697 after the calculation. This can be converted to binary with an online calculator or by hand, but we could also compress it into a hexadecimal value, which is more common than writing a long binary code. Again, an online calculator or a small hands-on calculation delivers us the necessary value we need for byte 1 and 2, and while I was at it, I also converted the rest of the binary values into hexadecimal.
Hello, and welcome to this presentation, Understanding I2C. This presentation will provide you with a brief technical overview.
I forget what I used I2C for, but I'm pretty sure it's the magnetic encoder, but I didn't do a pull-up resistor thing.
Of the I2C serial protocol and how it's used to transfer digital information. The Inter-Integrated Circuit Protocol, commonly called either I2C or I2C, was developed in 1982 by Philips. It's one of the most common serial protocols and, as the name implies, it's used primarily for short-distance data communications. I2C is a synchronous master-slave type protocol in which both the master and the slaves can send or receive data. It operates bidirectionally in half-duplex mode and can run at different clock speeds. Only 2 wires, serial clock and serial data, are used in I2C. In the remainder of this presentation, we'll go step by step through the frame structure and operation of I2C. We'll begin with a basic I2C topology. A master is connected to one or more slave nodes via two shared lines, SDA or serial data and SCL or serial clock. These two lines are each connected to a voltage, VCC or VDD, by a single pull-up resistor. We'll explain the role of these resistors later in this presentation. Note that devices can be added to or removed from the bus at any location and at any time. I2C nodes exchange data over the shared bus in the form of frames. Let's take a high-level look at I2C frames. An I2C master claims the bus by means of a so-called start condition. It then sends the address of the slave that it wishes to communicate with, as well as an indication as to whether it wishes to read data from or write data to the slave. The slave acknowledges its presence and its readiness, after which the data is transmitted and acknowledged. The communication is terminated by means of a stop condition. Let's now go back through this frame and explain each of these fields in more detail. In I2C, the idle state of both lines, SDA and SCL, is high. The start condition occurs when a node first pulls SDA low and then pulls SCL low. Pulling these lines down in this order is used to claim the bus, and the node that claims the bus is now the master. This procedure prevents other nodes from taking control of the bus, and thereby reduces the risk of contention, that is, two nodes trying to claim or use the bus at the same time. Once a node has seized the bus, that node also begins sending the clock signal that's used by both the master and the slave. Immediately following the start condition is the slave address, which is used to specify which node the master wants to communicate with. Each node on an I2C bus must have a unique fixed address. These are normally 7 bits long.
I think it's that the IC or the PCB itself has the pull-up resistors. I'm pretty sure that's why I didn't need to do it.
With the most significant bit first. I2C also supports 10-bit addresses, but these are uncommon. Addresses may be hard-coded for each device, but in many cases the address is partially configurable using external address lines or jumpers. For example, addresses for this board can be partially configured using 3 jumpers. In order to configure this address, both A2 and A0 would be jumpered, and A1 would be left open. At this point, it would be a good idea to pause for a moment to talk about the timing relationship between the data and clock lines in I2C. In this diagram, we can see that SDA does not change between the rising and the falling edges of the clock signal. Data is always read during the middle of the clock pulse. Expressed another way, we can say that during data transmission, SDA only transitions when the clock is low. This is necessary because an SDA transition when the clock is high would indicate the start or stop conditions. Immediately following the slave address is the read-write bit. This bit is set by the master to indicate if it wants to perform a read or a write operation. If set to 0, this means that the master wants to write data to the slave. And if set to 1, it indicates the master wants to read data from the slave. Recall that the standard slave address in I2C is 7 bits long, and in many cases, the read-write bit is decoded or interpreted as part of the address byte. The acknowledge or ACK bit is sent by the receiver each time a byte of data is received. 0 is an acknowledgement, and 1 is a negative acknowledgement, or a NAC. Recall that the I2C bus is idle high, so if the receiver doesn't actively respond by pulling the line low, this will be interpreted as a NAC. Every slave address or data byte is followed by an ACK bit. An ACK bit following a data byte is sent by the receiver to confirm correct by an ACK bit, as a NAC. Every slave address or data byte is followed by an ACK bit. An ACK bit following a data byte is sent by the receiver to confirm correct reception of the data. An ACK following a slave address is sent by the address slave to indicate that it's both present on the bus and that it's ready to read or write data, depending on the state of the preceding read-write bit. The address ACK bit is followed by the data byte, which is the actual information being transferred between the master and the slave. Although this is often the contents of a memory address or register in the slave device, this may be an address location itself. We'll talk about this more on the next slide. Data is
Okay, I think we're ready. Let's okay, wait, but I want to know about this PCB. Sears? Okay, whatever. Okay. So, we just do the wiring, I guess. I don't know what the wiring is supposed to be. I don't know what the address is either. How do you find all of the devices and their addresses? What is it called? Is that what it is? Oh, I could just use different buses. Bro, that's what you do. You just use different buses. If you have a conflict, you just use okay, wait. So let's reflash this thing. Awesome. Dude, how do okay. When I control F and then type something that doesn't exist on the page, Windows makes this annoying sound. How do I just disable that sound entirely? I know I did it before on my laptop, but now I need to do it on my desktop. Dude, it's so freaking annoying. Oh, baby. That's so much nicer. I can't stand that sound. It's literally the worst song in the world. Okay, whatever. I forget. Oh, shit. So bad at managing the stream, bruh. Okay. Okay, so it's flashed. Oh, wait. Okay. So we just blinked it. Now. Okay, wait. Now we want to connect it. Okay, so, yeah, I wish, we had a better way to do this, but, we don't. Okay. Clock. Wait, I'm gonna disconnect it. Okay. Clock data. Ground. Okay. VN ground SCL SDA. Is there like an Arduino? There's probably an Arduino library for this thing. Wait, is that written by Pololu? Oh wow. That's sick. Dude, I should buy a Pico or Arduino Nano. Okay. Okay. The fifth one down. Alright, so we should be all hooked up here, except for the ground. We don't have another ground, so we need to do that. No, that's not pin 4, that's pin 3. Okay. Dude, this thing has gotta stop doxing me. It's so insane. Literally my OS. Okay, cool. Okay. Oh wait, so now we're ready. So let's plug this thing in. Oh wait, but yeah, that's just because these are wrong. The clock is on 15 and the pin is on 14. Dude, what? What is the 0 for? Okay. What is that first argument for? Where's the constructor? ID. Oh, what? Wait, where does it say that? Is that on the pinout? Oh, yeah, there you go. Oh, I didn't know that. Wait. Oh, I didn't know that. All right, well, you learn something new every day. Okay, so cool. So now, how do we do it? Let's read the data sheet and be like real engineers about this. So this, in the table of contents, oh, there's no table of contents. Control it's probably under the control interface. Okay. OX52? Really? Ugh. Oh my fucking god. You really have to write all that code? Dude, I freaking love these embedded guys, man. They're so sick. It's almost certainly what I got. Oh no. $50 millimeters. Well, that's honestly fine for us. We don't need it to be that much bigger. But it said that it would go 2 meters. It said it was gonna go 2 meters. I don't know about that, man.
Hey robot makers, how you doing? Hope you're having a good day so far. So, do you want to know how to get the let me get these words right, vl53L0X time of flight laser rangefinder Working with MicroPython and the Raspberry Pi Pico. That's a bit of a mouthful, isn't it? So there's not very much information about this around the web, so I thought I would do a video on it, seeing as we've used this in the Smars Mini robot. So I've got a lot to share with you today, and maybe another robot that I found as well, another small robot. So let's dive straight in. My name's Kevin McAleer. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, so let's get over to Keynote. I'm just going to turn down. Paul says that's a bit of a mouthful. You're not kidding. That's the thing with techie content. It is a bit like that. So Raspberry Pi Pico. It's a bit different than so the MicroPython that's on Raspberry Pi Pico is a little bit different than the vanilla MicroPython and also the CircuitPython from Adafruit. And one of the things I found a bit of an issue was this little rangefinder, this blue chip that's on the screen at the moment. Getting that to work with Pico is a bit of a bind. So there's code out there that somebody's written, and there's code out there for the Arduino, but there isn't anything that works perfectly out of the box with the Raspberry Pi Pico. So there is now because I've made it. So let's go to the next slide and I can talk all about this. Okay, so session goals today. We want to get this thing working, get the vl53L0X board working with the Pico and with the Smars Mini, which is the little robot.
It's just dawning on me that it's gonna be like actually kind of tricky to get this working in Rust, but I'm waiting on this freaking solenoid. I need to go to Home Depot, get some wood. I design this stand for the canvases. That's an exciting stream that's gonna come up actually, but right now I'm kind of just down to lock in.
I designed. So we're going to understand what this board is all about, create some library code for MicroPython. You can just grab mine from GitHub. I'll share the link with you. That's probably what a lot of people come here for this video for in future when they're Googling this. Create some code to measure some distance. So it's probably an intermediate to advanced, I would say. It depends on how you use it. If you just use the code, then it's probably beginner to intermediate. If you want to do anything more than that, tinker with it, it's probably intermediate to expert, I would say. So this is for use in the Smars Mini, but you can also use it in lots of other places too. These things are ridiculously cheap. If you go to somewhere like AliExpress, you can pick them up for about £1, something like that. Your mileage may vary depending on which model you buy, where you buy it from, where you are in the world, and what the shipping looks like. So AliExpress, could be 60 days for that. So this is in place of the much larger rangefinder. If I just look over here. So this is a regular Smars robot with these kinds of rangefinders on the top. This thing is obviously a bit bigger than the little Smars robots. If we had that stuck on the front, I mean, it's in every way about this larger. So this little thing has to have something a bit smaller than one of these things. So that's what we're going for, something that can measure distance. So this time of flight sensor, what is it? How does it work? What are the specifications? Because I know some people love that kind of stuff. What's the cost where you can buy it from? And how do we get it to work with MicroPython and the Raspberry Pi Pico? So what is it? Spoiler, it's a laser. It's a laser power distance sensor. So it's a tiny little board that's designed for accurately measuring distance. It uses the I2C bus protocol for communication. If you don't know what that is, then you probably want to advise in. That's how it talks to the board. And it works kind of similar to how these work, but instead of using ultrasound, it uses light, uses invisible laser light. It's almost like magic. And it's available from your usual electronic suppliers, all good suppliers. And the actual chip itself is like about, I would say it's smaller than a grain of rice. It is ridiculously small. How they fit a laser in that, I don't know. So how does it work? So it uses something called time of flight, which is very similar, like I said, to the principle how the ultrasound works. So if you remember on these ultrasonic things, one of these is essentially like a loudspeaker and it fires out sound. It's higher than we can hear. This will fire out sound. When that hits an object, it bounces off that and then comes back to this other sensor, which is a microphone. So loudspeaker and microphone. With this, it works in the same way, but instead of it being a loudspeaker, it's a laser beam light. And lasers are very tight bandwidths of light. So unlike a light here, unlike a regular kind of light, these things are time taken. It's a bit like when you was a kid and you'd count, you'd see some lightning flash and then you'd count how many seconds between the thunder reaching you and when the light flashed. That kind of measurement is how this works. So the time of flight is how long does it take for those photons of light to bounce off the object and come back. I always thought that light was kind of instantaneous and it wasn't something you could measure. So how did I go about finding is what I remember. So how did I go about finding the code? What I remember. So how did I go about finding the code for this? So someone had very kindly written some libraries in the past. However, they only worked for a very old version of MicroPython, and MicroPython is a scaled down version of Python. And sometimes when new versions come out, they'll try and cut it back even further to try and maximize the amount of RAM that this chip has got available. Because if you put loads of stuff in the libraries and people don't use it, then it just takes up loads of space and means that programs don't run properly. And with things like the Pico, there is not very much RAM on there. Is it something like 156 kilobytes of RAM? It's tiny. It's got storage for files to store the source code, but the actual working RAM is very small. So any libraries and things that we use, we have to be really efficient on. And that means it can be really difficult to get somebody else's code working on your version of the MicroPython. So I believe Adafruit have got this working fine with CircuitPython. I'm not using CircuitPython. I wanted to get this working with the vanilla out of the box Raspberry Pi Pico MicroPython. So how did I do this? I googled stuff. I looked to see what other people's code is like. One of the problems with this is it's very, very technical. So there's lots of complicated maths involved. I didn't have to learn all that and learn how that chip works and how you communicate with that chip and the sequence of things and the timings, all that kind of stuff. I just wanted to sort of grab somebody else's code, maybe tinker about with it a bit, and then make it work with my code. So that's what I did. I spent a bit of time after work just making this code work with some test code that I'd written. So this is what I like to do as my approach. Find somebody else's code, try it out, troubleshoot the errors that come through, make it better, and then share it back with everyone. Because it's not very fair if you sort of just get this thing working and then don't share it when you're using other people's code that's they've given to the world free. So the library itself, you can grab my code from github.com/kevinmclear/vl53LX. I think it's L0X, is it? LX0? Let me double check that. I don't want to give you the wrong address before. It'd be terrible if I give you the wrong address for that. LX0. Okay, no, that's the actual name of the library. That's correct. That's fine. We'll go with that. And what we need to do is we need to upload that file to the Raspberry Pi Pico. I'll show you how we can do that too. I found I've had to do that a few times. So I'm actually not using the standard Raspberry Pi Pico. I'm using a Pimeroni version of the Pico that's called the Tiny 2040. So I'll show you that on the overhead shot. It's just this little chip. Just here. It's a tiny version of the Pico. You can see the Pico by comparison next to it. The off shot there. It's got an LED and 2 buttons, and it's got a couple of I/O pins on the back, and the actual Pico chip is on the back as well. It's just underneath there. You can't quite see it on the camera, but trust me, it's there. And I've just got this wide up there. That's the little rangefinder itself, and we can play with that in a second. So So that's what we need to do, and it is indeed demo time. So let's get over to, let's try this view. Let's see if I can get this to work. So I go over to VS Code, there we go. So at the moment, I'll just turn off that coffee thing for a second. There we go. You can see that bottom of the screen there sort of flickering away, and that's because it's taking lots of measurements at the moment. If I put my hand over it, you can see there it's measuring distances. So let's have a look at the code itself, and then we can come back to this and see how this is actually working. So if I come over here, so I've got 2 files in this library. So this is the GitHub library that I've created. So to show you there, there's just 3 files in it. There's a README file, which is just some text about the what this is all about. So what I've said in there is this will get you up and running with the time of flight sensor in MicroPython, specifically for the Raspberry Pi Pico. It's heavily based on the code from UC Eats, and that's his UC Eats GitHub. And I've just made some tweaks and made it work with limitations of Raspberry Pi Pico. So things to know, when I was testing this out, I found it was about 5 centimeters, exactly 5 centimeters out. So I've just taken 5 centimeters off all the readings that come back, and it seems working fine. So bit of a hack, but hey. And I've also simplified the results. So you have to do this sort of like start, take a reading, and then stop. And I thought, why do those 3 lines? Let's just have something that's called ping, and it can do all that for us and just return it in milliliters. So happy.
Oh, he said it was 5 centimeters off. Out is a weird, whatever.
So that's the README file. The next one then is the massive library itself. So I can see what's happened here. They've gone to the sort of manufacturer's site. So there's 4 things that it brings in there. It brings in a constant class. It's a bit overkill, to be honest. There's no need to do that. They could just pass those values in there as values. You have to say it's a constant beforehand. I don't know why they've done that. Python doesn't have the concept of a constant, which is weird. But the convention is that you provide the name of the variable in uppercase, and you just pass it a value and you never change it. That's the idea. So it brings in ustruct, which is a kind of C structure for managing bytes, sequences of bytes. We bring in utime, which is a MicroPython version of the time library, and we also bring in the timer. I don't think we actually use that. In fact, it says there timer is not accessed, so we could probably just comment on that actually. I originally had time in there. Time and utime are basically the same thing. Time is just a link to utime, and utime is that minimized version of the time library. So then we've got a whole load of constants. Now,
Did I just run this? I can't listen to this guy talk forever. TOF test? Okay, so wait. Do I just upload it? Okay, so just clone this thing. Okay. Dude, what? Oh my god, bro. I'm so sick of this shit. We're just gonna remove this from our path. Somehow, Windows, during an update, was like, you know what? We're just gonna shove this annoying version of Python onto your machine and put it on your path. Good luck, fellas. It's like, oh god. They think they can just do whatever they want. They think they can just do whatever they want. But they can't, bro. They can't stop me. They can't stop the fucking guy. Yeah, dude. Okay. That's so annoying. Oh, wait, dash V? Oh, how do you do which, bro? Wait, oh, wait. Did we apply it? Oh, nice. Oh, no, that's not right. Oh, but you know what? But that is the right Python. Okay. All right, so let's do this thing again. No. Should I delete the other thing from it? Wait, Windows apps Python? I think I went the like Microsoft Store version of Python. What is the recommended way to do this? Is Windows apps on my Okay, wait. Please say nothing. Bro, what the wait, is this right? I feel like this might have been different than before. No. So wait. Oh, is it on my user path? Wait, can we let's open up VS Code. Uh Oh, here we go. Okay, wait, which one is this one? That's the one I want. This one sucks. So both of these are fine. So we just need to remove this Windows apps thing. App data local Microsoft. Yeah. Oh my god. Oh, Control Z doesn't work. That's fantastic. Please tell me that works. Windows apps. I don't even understand. But we're just gonna delete it because wait, but we probably can't delete it. How do I make that my default? That's the one I want. I probably can't just delete that. But okay, wait. So if we do Python or oh, wait, hold on. Dude, dealing with paths, I maintain that dealing with paths is the worst part about programming. There's literally nothing worse than just dealing with file names all day. Holy fuck, I'm so mad. Okay, wait, what if we just add the specific Python one that we want? So it's we're gonna add this to our environment variables. Path, new, paste. I'm gonna close this. Remains to be seen if that's right. All right. Okay, cool. Finally, dude. Finally. So, I can't believe they did that. They just like mess everyone up. All right, so nice. All right. Okay. Presumably, if you just upload something. All right, wait. Let's just try this. We're just gonna do a little thing. So first off, I hate this. Uh. Um. Yeah, we can put it in here. I don't really care. Oh wait, actually, I don't want to put it in here because I have merge conflicts. Okay, I'll be back. I have to piss. Okay, so now I saw you working on programming. That's pretty cool, bro. These art by, yo, why are they like AIs trying to sell art? Why aren't they just more normal? I don't get it. Um. All right, so what I want to do is just demonstrate basically how MicroPython does things. Um. Okay. So in here we're gonna do okay, so in here we're gonna define a function. And all it's gonna do is print foo. That's fine. And now we're gonna have now we're gonna I'm pretty sure it's com10 And it's just ls. Okay, so what we just did is we upload. Uh-oh. I don't want to fuck this up. Oh shit. Okay, wait, that's actually fine. Okay. So now I want to start the okay. So, okay, so basically what we want to do now. Okay, sick. So now I should be able to say import func dot foo. So it's just like a normal Python module. So we don't really have to do all this weird stuff. So yeah, so okay. Now this is the part that basically when we run this on Rust, we are gonna have to do ourselves. And there's a ton of these constants and how to calibrate this and control this little chip. Okay, what happens in the read? It sends all these bytes, but why aren't these bytes constants? Wait, so what does this function do? Oh, okay. So it just loops over a list of tuples and it sets a bunch of registers. Okay, but like okay, wait, let's take this one for instance. Is that the only instance of this? Wait, hold on. Let me just open this up in VS Code. So presumably all of this is described in um did I close it? In this. Okay, so then I don't understand why there's literally so many of these. All right, can we just try it? Let's just what do you call it? You call it boot or something, or you call it main? Why don't we just click run? Why don't we do this? Wait, can we wait, no, we probably can't do this yet. Because first we need to what has it open? I think you have to disable this. Okay, so and now we want to upload oh wait, but we do need to change this to be yo, what's up? What's up? Okay. So okay, so I was able to get Blink running with the Pico examples or with Rust. That was nice, but the issue was there was well, the main issue is that now I want to interface with this sensor, this time of flight ranging sensor. But the problem with this ranging sensor is that you sort of need it's communicated with over I squared C. And so there's a specific data thing. You have to set all these registers and do all sorts of stuff. And so I found this, which is a micro Python version. And then I also found the Arduino version. And this is actually maintained by like a company that does this. So this is probably the most, I mean, it has by far the most stars. So our goal is first get it working in, no, I really want to do, because, like loops in MicroPython are still slow. It's still interpreted. So I would love to see if Rust is faster because, and there's a reason why I actually want it to be fast. When I was doing the RPM detection on the brushless motors, I was capping out at like 30% throttle. And My motors are 4 kV brushless, meaning kV is a way to describe the relationship between the voltage and the rotation speed. So I have 1450 kV 12 volt motors. So if you do 1450 times 12, the maximum I can RPM that I should be able to get is this high. But for some reason I just couldn't sample fast enough to get a reliable reading. Okay, so let's get this thing going. No, but honestly, Ampy, dude, it's so easy to just work with this. So now we want to we just want to run this. Okay, wait. So we're getting some noisy readings. Now if I put my hand here, oh my god. That's so sick. Okay. So we got this sensor. Two meters? Seems like it's more like half a meter. And it's really noisy. But if you're less than a centimeter or 10 centimeters, works pretty good. That's sick. So we're gonna be able to use this. But if you look at this code, it's pretty freaking random. Um, I don't think so, dude. Because it's a laser? It's a class 1 laser. Okay, it's a class 1 laser. I'm fine, bro. Okay, but I don't understand this code at all. Like, we're starting off the bat with like 20 constants. Undocumented, obviously. Do they even have a Yeah, it's retinal damage. I'm just not gonna look straight at it. I wanted to see if there's an I squared C example in this thing. Oh wait, actually I didn't want to open this. I wanted to this one. Oh yeah, here we go. Oh. That's pretty sweet. It's got all of the features of the thing. These hardware abstraction layers are really interesting. Dude, this is gonna be difficult. I don't know. Because the thing is, reading this data sheet doesn't even really help me. Oh, here's the schematic that I was looking for. So wait, do they have these pull-up resistors? Or am I supposed to do this? Presumably it's on the PCB. Oh wait, no, I don't know. Wait, can I see the pinout? Okay, so this is the pinout. Here we go. Let's read this. Okay. Shows the system level functional description. The host customer application controls using the device using an API. The API exposes to the customer application a set of high level functions that allow control of the sensor and the firmware. Functions include initialization, calibration, ranging start and stop, choice of accuracy, and choice of ranging mode. The API is a turnkey solution. It consists of a set of C functions. Oh, interesting. Which enables fast development of end user applications without the complication of direct multiple register access. The API is structured in a way that it can be compiled on any kind of platform. Wait, oh, maybe you know this, Ole. Can I, on something with no std, can I include C functions? I probably can. Because that would be the best, is if I could just have unsafe code in no std. The API package allows the user to fully benefit API user manual. I don't think that this is in this. Yeah, I mean, I don't know. Uh, yeah, I'll look, but I'm pretty sure that we're not gonna find anything considering the MicroPython one only has 20 stars. Oh wow, they even provide reflow method recommendation. That's pretty cool. Field of view. Okay, it's probably in. Oh, it's in this. This is the API. Yeah. Okay, so this is actually the real. Now, where do you get the code? There's probably a yeah. Can I see the quick start? Oh my god, dude, you're a freaking legend. What the hell? Dude, what the that's so surprising to me. Oh my god, people are so goated. And of course it's the one that has the most maintenance on it. Oh my dude. Ole, you're the fucking man, Ole. Oh my god, that's so cool that they have this. Making Rust fly. Of course this guy's got some freaking uh what is that, the K combinator? I'm pretty sure that's the K combinator. Wait. I'm pretty sure it's the K combinator. Yeah. Of course, dude. These guys are so sick. Copter Rust. Holy shit, man. So does it wrap the C code? Let's see. Yeah. Um Hold on, I'll be right back. I'll be right back. Okay. All right. So the question is, how do we get that library to work? Chocolate lover Raj. Dude, that's so silly. Okay. Yeah, this is an ESP. He used 5 pins. I don't know what the GPIO pin is for. Okay, that's the one that I have. Or wait. That's the one that I have. Okay, so the question is, yeah, how does this all work together? These are features. I don't even know what features are in Rust, to be honest. Because these are not dependency features. These are like Rust features. Then okay, so here's the dependency on the sensor. And then these are all basically interfacing with the microcontroller. I don't know what this is. It's an FCZ file. Oh, it's fritzing. Okay. Okay. Right. Okay, then there's a okay. So that's all good. Then this we just changed this from ESP flash to what is it? ELF to or no, wait, hold on. Which is the one that worked? The one that worked was this, and in here we didn't change this. Oh no, okay. Fair enough. Yeah. So we're using ELF to UF2, which what's an ELF file again? ELF file is a binary. And what's a UF2? A UF2 file? Oh, interesting. Okay. Cool, cool, cool. Okay. So some of this stuff is starting to make sense. Basically, let's go back to the... Oh, it's on GitHub, and it's this. Okay, so now let's look at the actual main. Okay, so first off... Oh my god. Okay, this seems pretty nice. So the question is, if we compare what this looks like to, not what that looks like, but what, oh wait, so here, basically the question is, in the library here, they say use HAL I2C. Wait, let me clone this so I can get some debug symbols. Oh, fuck. Motherfucker. Okay, so what we want to know, really, is where does this get used? So is this a trait? Presumably this is a trait. Okay, sweet. So it is a trait. And it just implements, yeah, read, write, read, transaction. Great. So presumably, embassy RP. So let's see, where does the... Okay, let's look at the I2C blocking example. Embedded HAL 1. Oop. Is that different? It might be different. Okay, let's look at the example then of not this, but of chocolate lovers. Thousand kilohertz? Bro, that's pretty fast. I haven't seen anything that high. Okay. Oh yeah, so wait. I shouldn't have closed that window. Okay, so I think the best thing that we should start out by doing is the scan. So this uses that thing, but what we want is what is that? Oh, that's this. Okay. Okay, so wait, what was the scan code? Dude, why does it continually run cargo check? I literally just indexed this shit. Why not? Why not? So wait, embassy. Is it all implemented in here? So I2C is implemented in here. I feel like HAL and embassy HAL are two different things, and we might not be able to get this thing to work. That's nice. Wait, can we just, I want to verify. So we're going to go to MicroPython GitHub. And we're going to try to find, is it in lib? No, it's probably not in lib. Wait, can we just go to the documentation? And can we go view page source? But no, that's retarded. Wait, why don't we just clone it and then look for class I2C? I just want to see if the way scan works in MicroPython is literally just by looping over all the addresses and then trying to write empty, whatever, an empty byte. Okay, so code MicroPython. Now we are going to search for, oh, wait, how, we have to find where the actual, because the thing is when you search, it doesn't sort it in a reasonable way. So this is not, you would kind of expect it to be in lib. I'm gonna ask ChatGPT. Thin pie? Ports is in ports. I can see that. There we go. Wait, but this is okay, I don't know how C Python works, or what is it called? Is it called C Python? Oh. Okay, so whatever. I'm gonna give up on finding where that is, but I'm guessing that's how it works. Let's just go here, copy this, go back to this, paste this in, and now we should be able to. I don't think I might have to register this somewhere because cargo is kind of annoying. Dude, the re-indexing of this thing is crazy. Okay. All right. Adder. For mutable ref. What? Wait, can we just copy? Let's just copy this. I don't know what changed. Oh, it didn't change. Okay, wait. I just don't want to function. I just don't give a shit. I think I need to do this. Yeah, so we just needed to import that trait, I guess. Let me try it one more time. Dude, this indexing is crazy slow. Unable to find mounted pico. I believe that is because, first off, what is going on here? Okay. I believe that's because it's already... Okay. It didn't print anything, though. Wait, how do I print? In Blinky, there was no printing. Let me, I think I have to do this every time. I'm gonna run this over here. It doesn't send it to standard. I don't know where it sends it. Where the hell does it print it? Ugh, that's annoying. What does the info do? It should send it to standard out. Okay, let's just do this. I'm running this from within VS Code, how it intended. So I remember the blink example ran, but all of the calls to info, the macro, they aren't printing to my standard out, my VS Code connected terminal. How do I print? Because it didn't run and it didn't show anything, but it did run and it did flash correctly, it seems. What? What is the point of that? Why can't you just print? Is it this?
Hey there, welcome back to the channel. In today's video, we are going to work with SWD, Serial Wire Debug Protocol. This protocol is available only on ARM architectures and it allows us to know what the microcontroller is currently doing by sending the log messages from the board to our host. So let's begin. In the previous videos, I said that turning on the LED is a hello world equivalent in the embedded world. But what if we want the microcontroller to print something out? Do we have to communicate with the external world using LEDs and Morse code? Absolutely not. There is a possibility to set up a communication between our development board and the host using semi-hosting. Semi-hosting is a mechanism that lets embedded devices, in essence our board, do I/O communication with the host, in essence our laptop. This sort of communication is mainly used for logging messages from the board to the host. Having the print debugger available through the ST-Link, it means we have all the necessary connections already set up, which is a great advantage of the Nucleo and Discovery boards, especially when we are learning how to use protocols and we are not that savvy with electronics. Reading schematics is a great skill to have, building your own board is the next level, and I won't be focusing on it for now. So let's
Can we just look at the okay. I wonder if there's a way to do that without having to freaking There's no search? Great. Wait, what the hell? Oh, that's confusing. You're gonna have two loops? I mean, that's pretty sick. I mean, it's nice that they have that example. Because this shows the state machine thing or whatever the hell they're talking about. But info is not working for me. Watch it show up with that annoying freaking thing. Look at this. Shows up with this stupid thing every time. So goddamn annoying. Oh, okay. What is RTT? Huh. Wait, how do I add it to the example? Wait, why don't I just start a new? Uh, okay, so what we're gonna do is I don't know if we need. We're gonna just try this. I'm gonna make a. Oh wait, what we should have done actually. Okay, then this I'm pretty sure we're gonna need. So we're gonna copy this. We're gonna copy. Do we need to copy all of this? I don't know about that. I think we just want to depend on the stuff that we care about, which is all of these. So first off, I'm gonna copy this into main. Then, do we need assets? Probably not. But I probably do need this. So we have the build RS. We have the... Okay. We're almost ready. Okay. God, I hate that I'm inside right now, but I just want to get this working. So we should be able to, let's see what went wrong here. Oh wait, we just have to refresh it. Okay, now we just need to add all of these. I don't know why that doesn't work, because this is installed. Oh, I guess not. Okay, great. So now we just need to add. Hmm. Are there features maybe? Let's see. It's interesting because in. Oh no, yeah, okay, all right. So yeah, so this is just literally examples. So okay, so we do need all of these features. Oh shit. And then embedded HAL. Oh wait. Why do they do that? Why do you alias it like that? Okay, what else do we need? Deformat. We need this. Embassy embedded HAL. Is that different? Oh man, I'm dropping frames, bro. Okay. Wait, let's see what we're at. Embassy RP does not have these features. How do... Okay, wait, how do you... Oh wait, I think it's just C features. Is it cargo feature or cargo features? I think it's this one actually. Wait, what the fuck? I think it's not this. Wait. I'm pretty sure it's not. To manage dependency. I'm pretty sure what it is cargo features. Bro. Wait. Didn't we just have that search thing? Oh my fucking god, bro. What the hell? Isn't there an installable subcommand of cargo that lets me list the features of a crate? List the features of a crate. So what if I just fucking... Jesus. This is bothering me, bro. Okay, then why did I even... Bro, I thought that there was something that actually worked. I thought there was something that worked. Okay, I think that this is just old. Okay, well, wait, the executor... Okay, we just wait now. Okay. I don't really get the difference between all these HAL crates. Oh yeah, wait. Okay. Embedded how? I think you just call it embedded how, right? Embassy time. Do I add this? Let's see. Embassy time. Okay. And then in here. What is it? It's deformat and deformat timestamp uptime. Okay, what else do we have here that we're missing? What is that? Do I even need that? Can I read what this guy was saying? What is SoCat? I feel like I'm doing this wrong. What is BSP? We need it. Wait, what? Wait, hold on. Spawner. I feel like it's a... I think we need this. Yeah, we need this. I don't think we have this. I could think we could just copy this and delete the freaking path argument. Wait, no, but we have this thing. Wait, let's add Cortex M. Oh wait, wait. Bro, I'm so confused. Oh wait. We just need to add this dependency. Oops. We're getting close. Perfect. Dude, we are getting so close to this. Dude, I wish it wouldn't open a fucking... I probably have a million of these open right now. Okay, so wait, so it needs to do this UART thing? Is that what he's saying? That's not helpful. Oh yeah, this is like one level down. But I don't understand how you connect to this thing or whatever. Okay, hold on. Okay, tell me what I need to do if I just want to log over the micro USB cable that connects my Raspberry Pi and my computer. I just want to see it in the terminal. The simplest way. Yeah, it has no idea what the fuck it's doing. Wait, what? Okay, first off, let's do blink. So let's get blinky. Oh wait, where is that? Okay, wait, how did they set that up? It's probably in the cargo.toml where it says. Whatever. include bytes. What was it? Is it in this? Okay, so wait. In Wi-Fi Blinky, include bytes, firmware, this and this and this. We'll just put it in here. Oop. Why is this all grayed out? Let's see if this works. Okay, perfect. Oh yeah. And we definitely need to add deformat to all of these, even though I have no idea what it does. It's so annoying to do this. Wait, had it. Okay. Wait, no. Oh, wait. What was it? Okay. It's probably some random thing. Probably this. I'm just guessing and I'm getting it right. Um Okay, so we're successfully blinking and we should just blink forever. Now, the question is, where the hell do we get this? Where the hell do we get the okay. Oh yeah, so I wanted to test if this works. Huh? Method to work. Will this be able to go just over the USB, or do I need one of those weird debug things? All I have is the Pico. I don't have anything else. Whoa. Oh. Oh, wait. I do this, then I run my... What? What is that? Wait, I know I should have this. Deploy. Oh, is that what's in my cargo toml? Oh, yeah. Mm, 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 mm. Okay. So let's see. Do I have that in Panic Probe? Yeah. Cortex M. Cortex. I honestly have no idea. Just adding random dependencies. Bruh. Dude, I don't understand what I need to do. Is this mine? No. Mouse so fucking annoying. Connect to serial after deploy. What does that mean? Oh, this bothers me so much. How do you print? Wait, can I just watch that video? Not this. Well, okay.
Let's get back to the main part. How can we ask the microcontroller to print out something on our screen? The Discovery book proposes to use ITM, instrumentation, trace, macrocell. We briefly discussed this protocol in one of the previous videos about HAL crates, but we are not going to be using ITM today, but serial wire debug protocol. So let's quick.
Is this all that showed up?
My name is Michał Wojciechowicz. I am a veteran developer. I work at Clickatech. I am organizer of this meetup, as I already said, I guess. But usually it is too expensive to afford, right? A famous piece of Polish literature. So yeah, but how it's done? Okay, so I wrote this small program that does this main function, right? We say hello world, it's why not, and then we print komentarz, księga, and so we print chapter by chapter. And if you go to if you look at how it works, it just prints huge strings. This is like tens of thousands of lines. I assure you this is a lot more than 60 kilobytes. So, how it works? Let's see if it works all. Yes. So we flash our microcontroller that I have to my computer, and it is printed. It is printed to my computer. Yes. So we
So I think what's happening is it comes back to this ELF to UF2 versus probe RS thing. He didn't show us how the wiring is set up. This is cool because it is slow. It's slow as hell, bruh. Okay, so ELF to UF2 dash D $1. I believe that gets set in this. Just change it back to debug. See, we get all of that. Wait, is he using... He's using ELF to... Wait. Wait, what is his... Here we go. So wait, here's what I'm gonna do. I'm gonna do so instead of this, I'm gonna make another one, just hello world loop, or let's just call it that. And then we're going to kill all of this, all of this. Okay, so we don't even need this. So, but what we want to do is we want to edit this thing to be this runner. Now we want to pipe it so that it works like this, which is we should be able to do this. So cat this. Okay. I found this example that uses deformat serial. No, serial with an S. Lol. Oh my god. Can you explain this and then also make it work for PowerShell? So this is, so we could just write this script. So what is the serial? Connect to serial after deploy. Okay. L to U to, oh, whatever. Okay. What are you supposed to call it? PS1. Dude. Microsoft is so silly. Okay. So now we want to change this to be flash and run. Wait, flash and log, right? Is that it? His was this and then cat that. So wait, why don't we just try it? -- release -- bin hello world. Wait, what? Wait, what? Oh, that's because of this ridiculous nonsense. I hate these profiles. Okay. So, program not found. That means... What exactly? That means that this was not found. Let me just copy the whole path in. Just whatever. Oh my god, bro. Windows development, bro. Windows development. Okay. Access is denied. That's presumably because it's open already. So I'm going to disconnect the pico. And we're going to try to flash it again. I'm honestly guessing it's still going to say access is denied. But a man can dream. I'm guessing it's this get content thing that's not working. Oh, wait. I'm dumb as hell. Wait, is it actually COM9? Let's see if it's hopefully it's not. Wait, it doesn't even see it? Wait, that's because we don't know what it will be. So I'm just gonna guess 9, which is like some silly ass shit. No, I have something wrong. Okay, if I just manually do this. So in here, if we undo. If we just do. What does it take? It takes the executable, presumably. So I give it target release. Oh wait, no. Target thumb release hello world. Okay, cool. So what does the serial argument actually do? Let's look at the documentation of this thing. Ugh, why doesn't that work, man? That's so weird. Dude, I really want to get this to print. All of these guys said they... Wait. Um... let's see. Is there any explanation of deformat? Wait, but what was that thing called? A debugger? Yeah. Oh wait. See, there's this whole. Okay, wait. Yeah, that's a Mac OS thing. Dependencies. Right. So, should I go down this road? I mean, it seems like the craziest. I really don't want to do that, man. But since this uses this, you can't actually so wait, so this is like totally bogus for me because well, maybe it's not just for this part of it, but like I won't be able to use uh this. Where was that guy? What was his name? I had him on my history.
Superpowers. You'll have to wire your picos like this.
Oh
Okay,
wait.
you do.
Okay, wait. Yeah, that's okay, wait. So is he gonna show me how to what is flip link? Dude, flashing. Oh my god. Assholes using GitLab. USB flash, oh, probe flash. Dude, this guy's article is great. Errors flashing with the probe, that's fine. Oh. Where does he actually run the code? Oh my god, there's so much to just, Okay, wait, where's the code? Article, probe firmware, my template. Presumably he just ran the template. So this, what does this say in it? Flip link, I don't know what that is. Do I need to add this? Is that a file in here? No. I kind of like how fast GitLab. Dude, GitLab feels snappy. If probe else. Okay, what if I just delete the serial thing? Do we think that's going to do anything? Let's see, what code does he actually run? Now that is cringe. Wait, what is this, like pre-processed code, dude? What the fuck? God. If probe, okay. End if, okay. Oh, so he's okay, so he's only logging if there's a probe. Should I really go through this to try to let me see what the wiring is? Oh, I don't want to do that. Ugh. Is there more? I'm just gonna comment. Dude, I don't know how to do it. Let's see. Rust printing RP 2040. Is there just a hello world in this actually? Presumably they're able to get that to work even just with this. Wait, hold on. What is it originally? Let me look at the actual source code. That's in Embassy examples. No. Wait. Am I missing that? Just randomly throwing dumb shit at the wall. Okay, hold on. rp.cargo cargo tunnel. Yeah, so okay. Interesting. So this is with that. So I'm pretty sure that probe RS handles the so really the question is with ELF2 UF2 printing to terminal ELF2 UF2. Wait, should I add Rust to this? I'm gonna try adding this. Just throwing in random shit. Where do you put this? Okay, you just put this here. And we are going to just, we're just gonna do this. But I don't think it does anything. So, release stuff. But what is the contents of release.py? Ugh. Okay, I think it's time to relax and not get this printing working. Um Okay, should I just send it? Ugh. Mine has this little housing on this thing. So if you look at this, wait, okay, I don't know if I have a connect. Actually, wait, they're right here. None of these are small enough to fit in this thing. It's so small. But basically, maybe I could just take it off. I don't know. I don't really want to do that. Okay, wait. My Raspberry Pi Pico W has its debug pins in a housing, but I don't know what type of cable I need. It's pretty small, but I won't be able to solder to it. What do I what kind of connector do I need to get? Two by five. Oh, SWD. It seems like it's only 3 pins though. Anyways, that's what I'm looking for. UART a two wire serial debug interfaces. But where do I buy the fucking connector? I feel like we might have some of these, but I am gonna go into Amazon. Ooh, an adapter kit. You have to put it together for yourself. Is it male and female? I don't even know if, I don't know, these low-key look too big. This thing is so small. Oh, here we go. Where are my calipers? I want to check. Whatever. Frequently returned item. Hilarious. Okay. I feel like we do have these JST connectors. So I'm going to put a pin in the... I mean, eventually I really, really want to be able to print. But, so I think it's this. What the hell is that, though? Too bad that I can't just solder directly to it. Where was that actual crate? So, but without printing, dude, this is gonna be a pain in the butt. Wait, actually, hold on. Yeah, but print line, I don't think you can just print line. So first off, it's insane that that exists. Dude, that's so wild. The Rust people are just so much better than everyone else. It's proving ground. Where was the, this is really what you want. Um, Whoa, they did this 6 years ago? Dude, that's nuts. That's crazy, man. 6 years ago they did this. Did I ever verify that things don't work if you have this? Um, is it called Blink Wi-Fi Blinky? Oh God. Where was that thing? Oh, my whole stream's gonna be fucked for 5 minutes anyways. Um, what is it called? The hell? Wait, where did I see that actually? Because I think in the embassy book is where. Oh wait, there it was. I think. Did they have a no probe? Oh yeah. I mean, it's more of a question. Maybe it's more of a question for how Elf to UF2 works, but I'm still gonna ask it on Embassy. I feel like I'm more likely to get a real response. Um, Okay. Um, is it, what is it actually? What's different? Oh yeah, link. Yeah. What have I tried? That's I guess maybe a better question is what have I tried? I don't know what I tried. I tried nothing and I gave up immediately and now it's someone else's problem. And that's how I solve problems in life. Make it someone else's issue. Okay, wait, what if we try to run this again? Wait, what happened over here? Oh wait. Yeah, no connected probes were found. I'm able to get the Wi-Fi blinky example to the examples RP. What is the path to this thing? Examples RP surspin Wi-Fi blinky.rs. In .cargo config.toml. My issue, I can't seem to get any. Is it possible to log information to my terminal without a debug probe? I'm new to embedded programming. Thank you. Where's my repo? Let me go to my my code is here with a when I do a cargo run dash release dash bin hello world, I can see that the pico is getting flashed. Let's see. Oh wait, and let's make sure that this. Yeah. I don't even need to add this. Why am I being such a stupid guy? Wait, let me just copy it so that I know what's up. Dude, anytime you change this thing, it has to recompile the whole freaking thing. I think I'm gonna ask my dad to see if we have JSTSH because I really don't want to spend $20 just to get this debug probe thing. Plus, there's no reviews on this thing at all. Also, why do these look so big? I mean, I'd be so mad if I spent $10 on this and then like okay, wait, let's see if it's done compiling. Okay, wait. First off, let's remove all this stuff that I don't think I actually need. And let's recompile it. I'm pretty sure okay. Wait. Deformat right? Wait, oh wait, you know what? My code is out of date. Wait. Oh yeah, here's what's happening. Wait, let me have a couple of them where it works. Okay, I feel like that might be the end of this stream. Is Brother, I just lose a follower? What the fuck? Okay. Not cool. Not cool. Let's see, does anyone actually respond to issues? Wow. Dude, I'm waiting for the Pico W, the Pico 2W. But like honestly, the Pico W is probably fine. Okay, it seems like should I send it? It's only $10. I'm just gonna be so mad if it. Ugh. Kind of really don't like the vibe I get from this. But these are male. Whatever. I do want to probe though. I really do. I mean, this does look like a JST. Hold on. All right, so I'm about to end the stream, and I'll probably restart it to do this CAD work for this woodworking project that I need to do. But where did we get? What did we do in the past 4 hours and 40 minutes? We the first thing we did is we hooked up the Raspberry Pi to the time of flight sensor. Then we got a Python reading from it, and we were able to read it, and we tested that it worked by doing this. So that was really great. That worked super easily. The next thing we wanted to do was start to see if Rust is faster on this, if we can sample faster. Not that we need it for this case, but we need it for our magnetic encoder. We want that to be as fast as possible so that we can read the fastest RPM possible, because my drone motors are 1450 kV, and at 12 volts that gives me a upper bound of my RPM being about 17,000, a little higher than 17,000. And so basically we want to run Rust because it's sick on the Raspberry Pi. So we are able to use this thing called Embassy, which is an embedded platform that is written in Rust, to do a couple of things. The main thing that we accomplished was being able to blink the LED on the Pico and flash it and sort of learn how the Rust workflow for the Raspberry Pi works. Then the basically back half of this stream, we just spent 2 hours, 2.5 hours, I don't know how long it really was, debugging why it is we cannot print to the terminal. And I'm sure that it's my fault and it's just a bunch of silly shit, but that is basically where we're at. And I hope was that we'd be able to actually, maybe in a future stream we'll do it, is get this time of flight sensor working in Rust. And then we can finally confirm whether or not Rust is